Electric dipole, it is a system of two equal and opposite charges, let's say minus and plus. Both magnitude is equal, one is negative, another is positive. Equal and opposite charges separated by certain distance. That the distance between these two charges, that this we mark as the center of this system, each charge, its distance from the center is equal to A. So total distance is twice A. Total distance is twice A. So this kind of system of two charges separated by certain distance is called as electric dipole. Dipole means two poles, positive and negative. Another is quantity related to it is electric dipole moment. Electric dipole moment represented by symbol P. It is a vector quantity and it is defined as a product of either charge and separation between the two charges. Here both the charge magnitude is Q. Separation between these two charges is twice A. Charge is the scalar quantity, but the separation, if you take as a displacement, the direction of this displacement vector, that is considered from negative to positive charge. As the direction of displacement vector is from negative to positive charge, so dipole moment vector P, its direction is also from negative to positive charge. Remember, electric field we discussed, electric field that starts from positive charge terminates to negative charge. So for dipole, direction of electric field is from positive charge to negative charge. So always remember these two are having opposite directions. SI of dipole moment is, as it is a product of charge and separation. For charge unit is coulomb, for separation it is meter, so unit is coulomb meter. Okay. Now electric field due to dipole on its axial point. Electric dipole, it is a system of two charges, equal and opposite charges separated by certain distance. Let's say charge minus Q and plus Q. They are separated by distance 2A. This is the center of dipole, and to find the electric field on its axial point, that is a point along the line joining the center of the two charges. Let's say at any point P, the distance of this point P from the center of the dipole, let's say it is R. From the center point P is at a distance R. To find the electric field to this dipole at this point P, what we need, that is, you know that electric field due to point charge is kq by R square. So you have both the charges. Now what you need, that is distance of each charge from point P. If point P is at a distance R from the center, then from the positive charge, what will the distance? It will be R minus A, as distance between positive charge and center is A. Similarly, negative charge distance will be R plus A. Now you have the distance of each charge from point P. Another one thing about the direction of electric field. You know that due to positive charge, electric field is radially outward. Due to negative charge, it is radially inward. So, due to this positive charge, at this point, if you show the outward direction, radial electric field, radially outward, this is the direction of electric field due to positive charge. If it is negative charge, then field lines are radially inward. So, due to this negative charge at this point P, direction of electric field will be along this direction. So both the directions are opposite. You can also see that the arrow length, that is different. E plus it is bigger one, E minus it is smaller one. Reason that is, you know, electric field not only a function of charge, it is also a function of distance. And for positive charge, distance is less, negative charge distance is more, and electric field is inversely proportional to square of distance. So if lesser the distance, strength of it is more the distance, strength of the field is less. That's why positive electric field strength is more, negative electric field strength is less. That's why if you want to find the resultant electric field at point P, you can take the vector sum of these two. So let us first find the electric field due to both these charges. So here we have considered electric dipole having charges plus q and minus q separated by distance 2a. We want to find electric field at point P at a distance r from the center of dipole. Distance of positive charge from P is r plus a, r minus a. So electric field due to positive charge is E plus is equal to kq upon r minus a square. Similarly, electric field due to minus q charge is E minus is kq upon r plus a square. Therefore, resultant electric field at point P is E. As it is axial point, you can write the axial is equal to E plus E minus. Therefore, you can write E axial is equal to the magnitude. If you want to write, you will take the difference of the two because both are in the opposite direction. So magnitude of E plus minus magnitude of that is kq upon r minus a square minus kq upon r plus a square. Therefore, the axial you can write as taking kq common 1 by r minus a square 1 upon r plus a square. If you simplify these two, you can write taking cross product r plus a square r minus a square, r plus into r minus is r square minus a square. It is 2 times, and therefore E axial is equal to kq. Now see here, expansion if you do, r plus a square is r square plus 2ar plus a square. R minus a square expansion is r square minus 2ar plus a square. So if you take the difference, only middle terms will be added, that will become 4ar upon r square minus a square whole square. As you know, dipole moment is the product of either charge into separation, that is q into twice a. Here we have q into 4a. So this quantity, if you write in terms of dipole moment, you can write q into 4a is 2 times dipole moment P into r upon r square minus a square whole square. So E axial magnitude you can write that is 2 times, you can say kpr upon this. Okay. So therefore, this equation you can also write as E axial is equal to 2 kpr upon r square minus a square whole square. Here r is the distance of point P from the center of dipole and a is the distance of each charge from the center of dipole. If this r is much larger compared to a, means that point P is far away from the dipole, and in that case you can neglect the value of a. You can write the equation axial electric field E axial that is equal to 2 kp upon, because when you neglect a is r raised to 4, 1 power will be cancelled, 2 kp by r cube. See, for point charge equation of electric field that was kq by r square. For dipole it is 2 kp by r cube, means it is inversely proportional to cube of r. It means that as you move away from the dipole, electric field decreases faster. Compared to a point charge, Here the decrease is more. Now the electric field will dipole on its equatorial point. Equatorial point, that is the, first of all, equator means it is the imaginary plane that is perpendicular to the length of a dipole and it is bisecting the length of dipole. Let here charge minus q and plus q. This is the center of dipole. So length of this dipole, that is 2a, and the center of that is at this point. So if an imaginary plane that is bisecting this length of dipole, then that is called as equatorial plane. Let me say on this equatorial line, at any point P, if you want to find electric field, and the distance of point P from the center of dipole is r. You know each charge that is at a distance a, point P is at a distance r, so distance of each charge from point P, distance of each charge from point P, according to Pythagoras theorem, it will be under root of r square plus a square. As these two sides are equal, these two angles are also equal, let's say these are theta. Now, to find the electric field at point P due to these charges, now we have the two charges as well as the distance also. So, due to this negative charge at point P, electric field direction will be inward. This is the direction of electric field due to negative charge. Due to positive charge, the direction of electric field at this point will be outward. So this is the direction of electric field due to positive charge. Also, you can find the magnitude. As both charges magnitude equal, distance is also equal. So electric field due to both the charge magnitude is also equal. Therefore, we can write electric field due to each charge is magnitude of electric field due to positive charge or magnitude of electric field due to negative charge, it is equal, and that is equal to kq by r square plus a square. Because here it is distance is under root of r square plus a square. So kq by r square, when you take the square of that, it becomes kq by r square plus a square. So electric field is equal. What is the difference? That is directions. Directions are different. So here, if you want to find the resultant electric field, resultant of these two, you can find this will be the resultant electric field. Now, how to find the resultant? There are various ways. Here, if you take the component, see, this angle is theta, so this angle will be also theta. This angle theta, so this angle will be also equal to theta. Now, you can take horizontal and vertical components of this electric field. So, if we represent here the components of this electric field in vertical and horizontal plane, due to this E plus, this is the direction of E plus. So due to this E plus, this component will be E plus cos theta. This component will be E plus sin theta. Similarly, due to E minus, this angle theta, this component will be E minus cos theta, and this component will be E minus sin theta. If you see the components, due to E plus cos theta, E plus sin theta, due to E minus cos theta, E minus sin theta. Cos theta components are in the same direction, they are adding up, whereas sin theta components are in the opposite direction, they will cancel each other. And that's why cancelling, because E plus and E minus magnitude is same, and that's why cancel each other. So resultant electric field you can write, therefore resultant electric, this we will call as equatorial electric field. So E equatorial magnitude is sum of these two, E plus cos theta plus E minus cos theta. Also you can write 2 times E plus cos theta, or also you can write 2 times E minus cos theta. Reason, E plus E minus magnitudes are equal. And that's why if you put these values, it's 2 times E plus or E minus values kq upon r square plus a square into cos theta. From this right triangle you can see cos theta is adjacent upon hypotenuse, and that's why cos theta value will be a upon r square plus a square power 1 by 2. That's why E equatorial equation you can write 2aqA upon r square plus a square is to 3 by 2. Power 1 plus 1 by 2, that is 3 by 2. Now twice q into k, this quantity is nothing but dipole moment, and that's why you can write kp upon r square plus a square is to 3 by 2. This is the equatorial electric field. Now again, if this r is much larger compared to a, you can neglect the condition. You can write if r is greater than a, then what is the value of equatorial electric field? That will be kp upon a0, so it will become rq. See, axial equation was twice kp by rq, equatorial it is kp by rq. It means that during dipole at a distance r on its axis, if electric field is spread, if it is, let's say, E, then at the same distance on equator it will be E by 2, because axial electric field, that is 2 kp by r cube, equatorial is kp by r cube. So you can write the relation axial and equatorial as E axial is equal to 2 times E equatorial. This is in terms of magnitude, but directions are different. Okay. Next is torque acting on dipole placed in uniform electric field. You know, uniform electric field can be represented by parallel field lines with equal spacing. That the strength of this electric field is. In this, if electric dipole having charge plus q and minus q separated by distance twice a, if it is placed here, the forces acting on this dipole are on positive charge it is q into E acting in the direction of field. On negative charge it is acting q into E in the opposite direction of field. Because it is a negative charge, so minus QE, and that's why acting in the opposite direction. Equal forces are acting in the opposite direction, but these forces are not on the same line. And that's why we can say net force acting on the dipole is 0, but due to these forces, as they are not on the same line, there is one more effect of these forces, that is called as rotational motion, that will take place. And this phenomenon that is called as torque acting on a dipole. As you know, torque is the either force into perpendicular distance between the two forces. So here, if you write the equation for torque, represented as tau, either force, that is magnitude, is q into E. A perpendicular distance between these two forces, say positive force F plus QE acting along this line, negative minus QE acting on this line. So perpendicular distance between these two forces is this distance. If this angle is theta, you see theta is the angle between which direction? This is the direction of electric field. This is the direction of dipole moment. So we can say theta is the angle between electric field and dipole moment. Then for this right angle triangle, for this opposite side upon adjacent, that is sin theta, you can write, if you mark these 3 points as A, B and C, you can write sin theta is equal to BC upon AC, that is BC upon AC is twice. Therefore BC is equal to 2A sin theta. So you can write the equation of this torque QE into twice A sine theta. Here Q into twice A is nothing but the dipole moment, P is the electric field to sin theta. So theta is angle between direction of P and direction of P. It's angle between vector P and P. Therefore, this quantity torque you can write in terms of vector notation as P cross E. As you studied in 11th standard, A cross B is AB sin theta. With P cross E, that is PE sin theta. So, equation for torque acting on the dipole can be written as torque equals P cross E. So, from the equation you can say when the torque will be maximum, that depends on the value of theta. If theta is 0 degree or 180 degree, in that case, value of sin theta, sin 0 or sin 180 degree, this value is 0, and therefore in that case torque is 0. This is the minimum value of torque. Whereas if theta is 90 degree, then cos this sin 90 value is 1. Therefore torque will be maximum. Torque will be P into E, that is the maximum value. So this way we can find the value of torque acting on dipole or whatever its orientation. Putting the value of theta, you can calculate the value of